Probably the easiest way to go about this exploit is to use this 160 byte space to make a longer jump backwards into our buffer and embed our shellcode there. This, however, would not be as fun as implementing an egg hunter. An egg hunter is a short piece of assembly code which is safely able to search the virtual address space for a signature or an egg, which is a short string signifying the beginning of a larger payload. The egg hunter code will usually include an error handling mechanism for dealing with access to non-allocated memory ranges. Let's look at the following egg hunter written by Matt Miller. Do not be intimidated by this assembly code. It becomes much clearer when we watch it in action in Ollie. Our egg hunter uses the EDX register as a pointer to scanned memory. We start by going to the last address in the current memory space that EDX is pointing to, and then point EDX to the first address in the next page. We can see this here and here. We then check that this address space is valid using the nt-access check and audit alarm function. We can see this being done here. If this address is invalid, we hop to the next page by jumping back to this function. If our address is valid, our egg hunter starts searching that memory space for the signature that we've planted before our shellcode. Our signature in this example will be root root, 2 instances of the word root. So let's see how this egg hunter works. We start by storing the first half of the signature in the EAX register. We then initialize our pointer with our current checked address. We effectively move the address space that we are pointing to into the EDI register. We then compare the contents of EDI with this string to see whether we have reached our signature or our egg. If we haven't reached it, we should increase our memory counter by 1 by jumping back to this function. If we have met it, let's look for the second instance of our egg. And if that was not found, once again, we'll increase our address page by 1. However, if it was found, which indicates that we have hit our egg and that our shellcode is immediately after it, we should jump to EDI, where our shellcode awaits for us. Once again, this sounds much more complicated than it is. This code will become much clearer once we see it in Ollie. Let's integrate this egg hunter into our exploit. I've got the binary that generates the egg hunter shellcode. Let's run that and see what the output looks like. We need to give the C-style parameter and our 4-byte egg. So let's quickly do that. And our egg will be root. Great. So this is a 32-byte egg hunter shellcode which has root root as its egg or signature. Let's copy these bytes and carefully place them in our exploit. As we saw earlier, our first stage shellcode brings us to the end of these NOPs, and we have around 160 bytes of breakpoints which we can use to execute our code. So let's start by putting our egg hunter right here. So I'll copy all of this and I'll put it right here. And we'll take this new buffer into account, this new egg hunter. We said that it was 32 bytes in length. So let's deduct 32 bytes from this buffer, which should give us 134 bytes. And while we're editing the exploit, this would also be a good time to replace these bytes with our first stage shellcode, which we created in order to jump back into our buffer and reach a larger space for our secondary shellcode. So let's quickly do that. We'll simply paste the binary copy of the bytes which we copied before in Ollie, and we'll insert these bytes instead of this buffer here. So this was our sub ESP 58, and this was our second sub ESP 58, and these were the bytes we used for our jump ESP. So once again, this is our first stage payload. So let's save this, create our playlist file, and try to run this under Winamp. We've created the playlist file. We'll attach Winamp. Once again, we won't forget to put a breakpoint at our return address. F2 for a breakpoint. And let's open our malicious file. We hit our breakpoint, and ESP currently points to our first stage payload. So let's jump there. I'll press F7 to step into our call function. And we hit our stack adjustment shellcode, which will give us a bit more space for our secondary payload. So let's take these instructions. I'll press F7, F7, and ESP is now pointing to these NOPs over here, which will bring us eventually to our egg hunter. So let's follow execution. I'll take another F7, and we've got a few NOPs before our egg hunter begins.